In our previous lesson, we took a look at graphs and tables and determined whether or not something is a linear function, but we will often see things written as equations. You might have studied slope-intercept form before of y equals mx plus b. This is what I like to use to check to see if something is a linear function. Every linear function can be rearranged to look like this, or in this case, it already looks like that. We've got y equals mx plus b. Our m is 3 and our b is 6. So yes, this one already fits that form. This one does not. You might recognize this as standard form. If you're familiar with it, you can go ahead and say, yes, this is. If you're not, you can go ahead and rearrange and check. Let's solve for y by subtracting 2x. And we get 6y equals negative 2x plus 18. Divide by 6. Divide both of these by 6. And we get y equals negative 1/3 x plus 3, which again is in slope-intercept form. So this, yes, is a linear function. It fits that. This one is not. We've got to get our x without the square, and in order to do that, our tool is to take the square root. But the problem is, if we take the square root of this side, we'll end up taking the square root of that side. So by taking a square root and trying to fix things over here, we end up with the square root of y over there, which does not fit our form y equals mx plus b. So this one is not a linear function, and the trouble that's caused is from this 2 right here, the squared. That makes it so it is not a linear function. We've got a few more examples we'll take a look at. There are infinitely many of these, so you've got to be able to use your skills of algebra that we learned previously to check. All right, the cubed root of 8 might be tempting to say, oh, this is not a linear function. However, if we think about this, the cubed root of 8 is simply 2. And if we did that calculation right here, we end up with y equals 2 plus x, or x plus 2 if you prefer it that way, which fits slope-intercept form. Looking back here, we can see that we have a y and we have an x, and there's nothing else that's messing up the y and the x. So that's actually the key. It doesn't matter what this is, even if it ended up being a really ugly number like a decimal instead of a nice whole number like 2, this would still be linear. This one, however, is not, because the cubed root is attached to the x term. I cannot undo that without causing the y value to change, so this one is not a linear function because of this cubed root on the variable. On this example, you'll notice we have variables at all sorts of different places. If we combine those together, add the x to both sides, we get y equals 3x minus 2/3 y. Add the 2/3 y, add the 2/3 y. We end up with, that is, let's see, 3/3 plus 2/3 gives us 5/3 y equals 3x. We'll multiply by 3/5 to eliminate that, and we end up with y equals 9/5 x, which we have just our y and our x. That is again linear, so yes, this one works. This one does not. If we distribute that, we're going to see that 4x times 8 is 32x, which is fine. 4x times negative x gives us negative 4x squared. That squared is what messes us up. So we cannot do this. It's like the one we saw before where we ended up with a squared. This one again is not, and we can just take a look right here. Linear functions y equals mx plus b do not have the y and the x multiplying together anywhere. So I'm not even going to try to rearrange this because we have those two multiplied together, which makes it so it is not a function. So lots of examples, try to rearrange, or if you can recognize things like that right away and just say, hey, this is not a function, not a linear function, then you can use those as well. Thank you.